Alright, I'm Landon Miller, and my paper was on robocasting using hydrogel inks. Alright, so the name of my paper was Robocasting of Structural Ceramic Parts with Hydrogel Inks. The specific scope of it was to demonstrate mechanical properties of the printed parts for both oxide and non-oxide ceramics using the robocasting technique. The reason for this is because although the robocasting technique is about 20 years old, there's not a lot of studies based on the mechanical properties of the printed parts. It's hard to find information on it. The key question they really addressed was what defects resulted from this printing process are present, and how do those affect the mechanical properties. So which ones are really which ones affect the actual parts the most, and how can we control those or compensate for those. The materials used were aluminum oxide for the oxide ceramic and silicon carbide for the non-oxide ceramic. The specific conditions they looked at were yield stress and the printing defects. For the yield stress, they used a Discovery HR1 testing machine, and for the printing defects, they looked at it with a scanning electron microscope and just kind of visually inspected and looked at what they saw. For the yield stress, as you can see, they plotted both the aluminum oxide and the silicon carbide here. They had the testing parts were 40 millimeters long by 3 millimeters by 2 millimeters. They were bars, and basically what they saw were the aluminum carbide and the aluminum oxide and the silicon carbide were very similar. They added Dolopix to the aluminum carbide because they believed it would kind of stabilize it a little bit, electrosterically stabilize it. They thought it would make it a little bit stronger, which it did a little bit, but it didn't really help too much. They added 0.5% weight of Dolopix to it. They also tested these against colloidal inks, which are what are traditionally used with robocasting, and they didn't put those on the graph, which is a little bit aggravating, but they said that they concluded that these were comparable to the colloidal inks. They were very similar. So the yield strengths between the two materials were very similar. The Dolopix helped the aluminum oxide a little bit, and these were comparable with colloidal inks, which are traditionally used. Next thing they looked at were the printing defects. Like I said, they just used the scanning electron microscope, and as you can see there, kind of like the most overwhelming defect right there is just the surface defect, which is just kind of a product of the actual way they print these, which it's just layer by layer extruding this gel out, so it's going to leave those surface ridges. So that's the most overwhelming feature. To help compensate for this, you could use a smaller nozzle, but that's also going to increase your build time, and it's also going to increase pressure at the nozzle. Depending on which printer you're using, it may not be able to handle that increased pressure at the nozzle. You could polish it or use some kind of other post-process technique to kind of bring down those ridges, but those are the best techniques you'd use. The next biggest surface printer property would be the actual in between the layers themselves. They would have air bubbles trapped. There's not really too much you can do for that, but you can change the print orientation just so you know which direction. Depending on how the part's going to handle the stresses, you know which direction is going to handle those stresses. You'll know which way the actual layers are going. Other than that, they also had bubbles within the gel extrusions themselves. To help with that, they would defoam the gel first and mix it, and that would help to mitigate those bubbles within the layers themselves. And then they also had surface pores after sintering, but they said that didn't really affect it too much, and there wasn't really too much you could actually do about that. So the biggest defect would be surface defects, and that could be minimized by polishing or using a smaller nozzle. So the conclusions are both oxide and non-oxide ceramics are viable materials to use with the robocasting technique. The defects can be minimized. The surface defects can be minimized by the small extrusion nozzle, strategic print orientation, or utilizing post-printing processes such as polishing or sanding or something of that nature. My critique of this paper was that they could have used a little bit more data, more information on the equipment used, maybe a little bit more in their graphs, but other than that, it was a pretty informative paper, and I think it did its job pretty well.